71% of Earth's surface is covered by the ocean. But if you could drain all that water, you'd be amazed by what you would see. Continental margins, ribbons of life connecting land and the deep ocean, trenches 10 times deeper than the Grand Canyon, and the mid-ocean ridge system, the world's longest mountain chain, longer than the Rockies and the Andes combined. The mid-ocean ridge system is shaped by movement in Earth's crust. The crust is made up of slabs called tectonic plates. These plates slowly jostle for position, moving at about the same speed that your fingernails grow. For billions of years, the tectonic plates have been on the move, changing the arrangement of land and sea. Take a look at the position of the world's continents today. As we move back in time, watch how they change position. Millions of years ago, Australia was closer to the South Pole. Long before it was part of Asia, India was its own island. The Persian Gulf was wider. Africa was split in two parts, as was North America. Florida was completely covered by water. Long ago, South America and Africa were joined, fitting together like two pieces of a puzzle. 240 million years ago, Earth looked very different. All the land was joined together in one supercontinent called Pangaea. And there was one super ocean named Panthalassa. Today, the plates are still on the move, bumping and sliding against one another. Movement at the plate boundaries results in most of the world's volcanic eruptions, including those underwater. Plate movement can also trigger earthquakes. Each dot in this view of Earth represents an earthquake that happened within the past 50 years. When an earthquake occurs underwater, it can generate a tsunami, a giant ocean wave. That's what happened in December 2004, an earthquake at the meeting point of the Australian, Indian, and Burmese plates uplifted a massive section of seafloor. It created tsunami waves that radiated outward, moving through deep water at the speed of a jet plane. By the time the waves reached shore, some were as tall as a 5-story building. 250,000 people lost their lives. The ocean's overwhelming power reverberated across the globe. The water in the ocean is constantly moving. Every drop of water is connected. Imagine dropping yellow rubber duckies at different points all across the ocean. In a month's time, some duckies will travel great distances. Others will only creep along. At first, their movements seem chaotic, but underlying the confusion is a very complex system of surface currents. These currents, seen here in yellow, are driven primarily by the force of winds. Slightly deeper currents, seen here in red, act like rivers within the ocean, flowing more steadily in a specific direction. These currents affect our weather. The Gulf Stream in the northwestern mid-Atlantic and the Kuroshio in the Pacific move warm water from the tropics to the North Pole. For centuries, equatorial currents in the Atlantic, Pacific, and Indian Ocean basins have carried sailors across the globe. These currents, along with the trade winds, influenced history by shaping trade routes between continents. They helped bring Christopher Columbus to America. The circumpolar current around Antarctica is unusual because it makes a complete circle around that continent. This current keeps Antarctica isolated from the rest of the globe and helps keep it even colder than the Arctic. A third level of currents, seen here in purple, moves slowly thousands of meters below the surface. 90% of all the water movement in the ocean occurs at these depths. Put all the currents together, and you see a mosaic of moving water. A mosaic that moves heat and nutrients across the globe. Scientists simplify the mosaic into a model called the ocean conveyor belt. In this model, deep cold currents are shown in blue, and warmer surface currents in red. The conveyor belt begins in the Atlantic near the North Pole. Deep cold water travels south toward Antarctica. Then, the cold water rises back towards the surface and gets warmer. The warmer currents return north toward the Arctic, where the cycle begins again. It all sounds fast, but in fact, the journey can take as long as 1,000 years. We call the ocean by many names: Atlantic, Pacific, Indian, but it's really one.